Students, this is the Peer Teach video for problem key question number 5. We're going to be doing our basic graphing over here, and on the right, you are going to show all computations. And all your math work here, I'm not going to do that for you, and you're going to do your own right up here. But let's get this problem set up to begin with. We have here a quadrilateral, and we're going to graph. J is at -4, +3. Always put your coordinate points on there. K is at 0, 1. L is at 0, -3. And M is at -4, -1. We're going to connect those. Our goal is to prove that triangle. We do this in 2 different colors. JKL. So there's a triangle here. J, K, and L. That's a triangle. Is going to be congruent to LMJ. LMJ. Now, quick recap. There's 4 ways to make triangles equal. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. 4 ways to make triangles equal. There are 3 equations that we use on a coordinate plane. Midpoint, so far, slope, and distance. So we're going to have to combine these 2 concepts. Somehow we need to get angles and sides congruent using midpoint, slope, and distance. So let's go through this logic, and this is the primary logic that you need to teach your classmates. It's very important they understand these 2 concepts. If you wanted to show that 2 lengths of 2 sides were congruent, in other words, if we wanted to get sides congruent, a side congruent to a side, would you use midpoint, slope, or distance? Think about that just for a second. Try to answer that on your own. Lengths congruent. We should use the distance equation. Distance equation would give us the length of sides, and then we can show that the lengths are congruent. Now, angles are a bit trickier. We cannot directly show angles are congruent using midpoint, slope, or distance, but we can show that 2 sides are parallel. Remember, we can show 2 sides are parallel. So I'm going to do a little demo here. Parallel sides. Let's make a stir stick. Using the slope equation. Remember, slope equals slope. The lines are parallel. And if they're parallel, you get all kinds of congruent angles. If lines are parallel, we know that alternate interior angles are equal. That's armpits of the Z. We know that alternate exterior angles are congruent. And we know that corresponding. That would be 1 in, 1 out, same side. That's the orange. So the question is, how can we apply either slope or distance to get the triangles equal? Well, I got good news for you. Technically, all 4 situations, all 4. I want you to teach this step and then give your classmates a choice of what to do. We do have one freebie here. Keep that in mind. You have one freebie to work with. You don't even need to do any computation. You can say at some point in your proof that JL is congruent to JL, and that's going to give you a side that's reflexive. So you have one side to work with. Now, if I wanted to get these angles congruent here, opposites of Z, if I wanted to get a pair of angles, I would have to find the slope of JK and ML. If you find the slope of those, and you can show the slopes are equal, you can show that the angle KJL is congruent to the angle MLJ because of armpits of the Z, and that would give you a pair of angles. So you'd end up with the sides in the middle and a pair of angles. So you have a side in the middle, then a pair of angles, and then you can show using distance, find the length using distance, and that would give you another pair of sides. So you could do this by side, angle, side. But it's important that you realize there's more than one way to shoot here. You could also do slope all 4 sides. And if you do slope all 4 sides, you could get these armpits of the Z. If you do slope all 4 sides, let's recap here. We can say that down the middle, JL is equal to JL. That gives us a pair of sides. Then, if we show that these 2 sides are parallel, the reds, using slope, we can get armpits of the Z. That would give us a pair of angles. And then from the same sides, if we use distance, we can get length. And that would also give us a pair of sides. So using a combination of slope and distance, you can get side, angle, side. Or, again, reflexive down the middle. You could just use, we could use the distance, that gives you a side. You could use the distance equation to show that these are equal. Distance. And then you can use the distance equation to show these are equal on this side, all 4. Distance. So that way you're doing distance 4 times, and that's going to give you side, side, side. And another way you can do this is the fact that if you, again, you have your reflexive down the middle. If you do slope both ways, slope here, show the slopes are equal. Slope here, show the slopes are equal. You can do armpits of the Z both ways. And that's if you like the slope equation. You have to do slope 4 times. You have the side down the middle because it's reflexive. But then you have a pair of angles here. You can show are equal because of alternate interior angles. And a pair of angles here, alternate interior. And that's going to be angle, side, angle. So there's several ways to do this. Choose whatever method you prefer. Show all your computations. And then do your summary.